Hi, this is Algebra 1, Lesson 8-3, Quadratic Functions in Standard Form. In this lesson, we'll be able to graph quadratic functions using standard form. So the lesson vocabulary is standard form of a quadratic function. Let's look at explore and reason. Three functions of the form f of x equals ax squared plus bx are graphed for a equals 2 and different values of b. So we have the same a, which will determine the width of the graph, but we have different values for b. So we want to know what b does in this situation. So if you recall last lesson, we had a quadratic function in the form ax squared, right? But we had h and k as well, right? So ax minus h plus k. But this b is going to be the second term, the coefficient of the second term. So if you remember polynomials, you can have the x squared and x and then the constant as a polynomial, right? That's the standard form of quadratic polynomial. So what does b do? What does the coefficient in the second term do? Well, look at that. So the red graph shows when b is equal to -2. The blue graph shows when b is equal to -4, and the green graph shows when b is equal to -6. So we're looking at these values, okay? As you can see, they don't necessarily change the shape. They look like they are translating, right? They're not necessarily getting wider or narrower. They're just moving, okay? So if you look at the vertex, it's the vertex of the red one. Whoops. The vertex of the red graph is here. 1, comma, wait, that's 0.5, comma, -0.5. And then the vertex for the blue graph is here. That is 1, comma, -2. The vertex of the green graph is right here, 1.5, comma, -4.5. So what do the graphs have in common? They have the same shape, but they have different vertex, right? So all three graphs are parabolas opening upward. They're facing upward. G has vertex of 0.5, comma, -0.5. Let's write that down again. And H has vertex of -1, comma, -2, and J, the green graph, has vertex of 1.5, comma, -4.5. Okay, so these are the different things. Part B. What do you notice about the x-intercepts of each graph? What do you notice about the y-intercepts of each graph? So if you look at the x-intercepts, we have these two for the x-intercept of G. The x-intercept of blue is still 0, 0, but it has 2, 0. 1, 0, and 2, 0. And then the other x-intercept for the green graph, J, is 3, 0. So you see a pattern, right? So the x-intercepts they all have 0, 0 as an x-intercept, but the other x-intercept will be 1, 0, 2, 0, and 3, 0. It increases, the x value increases by 1, right? So what about the y-intercepts? You see that there is only one y-intercept for each graph. The curve, the parabolas, intersect the y-axis only once, right? And they all go through the point 0, 0. So they have the same y-intercepts. So all three functions have one y-intercept at 0, 0. G of x has another x-intercept at 1, 0. And then h of x has another x-intercept at 2, 0. J of x has another x-intercept at 3, 0. All the functions have the same y-intercept at 0, 0. Part C, look at the ratio b over a for each function, okay, and compare it to its graph. What do you notice? So what are we talking about when we say b over a? We're looking at these values, okay? So if we see their equation, we can see b and a, the values for b and a. We have the same a's, right? A's are going to be 2. But b is -2 for g, -4 for h, and -6 for j. So if we figure out the ratios for each one, b over a for g is -2 over 2. b over a for h is -4 over 2. b over a for j is -6 over 2. So if you simplify them, g has a b over a ratio of -1. H will have -2. J will have -3. Okay. So for g of x, the ratio of b over a is -1. For h of x, it's -2. For j of x is -3. So each of the values of b over a is the negative of one of the x-intercepts of the function's graph. You see that pattern? For instance, g of x has x-intercepts at x equals 1 and x equals 0 and x equals 1, and its ratio is -1. Okay, so those are the patterns that we saw from these graphs that have different values for b, but have the same values of a. Let's look at the essential question. How is the standard form of a quadratic function different from the vertex form? We'll see. Let's look at example 1. Relate c to the graph of f of x equals ax squared plus bx plus c. So, what information does c? Now the c here is constant because we don't have any variables with it. It's just going to be a number. Okay? Provide about the graph of f of x equals ax squared plus bx plus c. You're going to graph several functions of the same form. And you're going to look for a connection between the graphs and the value of c for each function. So we're going to do the same thing as we did previously. We're going to have the same a and b, but now we're going to have different values for c so that we see how c affects the graph of parabolas, right? So here we have c is equal to -3. And then second graph, c is equal to -1. Third graph, c is equal to +1. We see that the graph is the same. The shape doesn't change, but it moves. It moves upward, right? So the value of c corresponds to the y-intercept. It goes upward of the graph of this. So if you look at the y-intercepts, you see that the y-intercepts go up depending on your c. Your c represents your y-intercept because whenever x is 0, that's the definition of y-intercept, right? Whenever x is 0, that's where your graph intercepts your y-axis. So when x is 0 in your equation, these are 0. So whatever is left is your constant. So your constant is going to be your y-intercept. And that was the same for linear equations, right? And that also works for parabolas, the quadratic equations as well. Let's look at try number 1. Evaluate f of x equals ax squared plus bx plus c for x equals 0. How does f of 0 relate to the result in example 1? So plug in when x is equal to 0. You're going to plug it in here, and basically you're going to solve for the y-intercept. And how does it relate to the example? See if you can explain using the patterns you see. Pause the video and come back when you're ready for answers. Okay, are you ready? So when you evaluate that, what do you get? F of 0 is equal to, so that's 0, C. C is whatever we have. We don't know C, and that's okay. Whatever the constant is in that form will be your F of 0, and that would be your y-intercept, okay? So from example 1, this means the y-intercept is 0, C, whatever the C is, right? So let's write that down. F of 0 is equal to C. And from example 1, this means the y-intercept is 0, C. Okay, for any form in this form. ax squared plus bx plus c. Okay? Let's look at example 2. Well, let's look at the next page. We have a concept of the standard form of a quadratic function. So your function f of x is equal to ax squared plus bx plus c, where a, b, and c are numbers in your equation, where a is not equal to 0. If a is equal to 0, you just have a linear function, and it's not a quadratic function anymore. Okay? The value c is the y-intercept of the graph. This is y-intercept of the graph. The axis of symmetry of the graph is the line x equals negative b over 2a. Okay? So whatever your a, your coefficients of x squared and the x is going to be the axis of symmetry. So if you have all these terms, then look at your coefficients. If you have the terms and you don't see a coefficient, that probably means the coefficient is 1. Okay? Doesn't mean there's no coefficient unless you don't see a term and your coefficient is 0. So if you don't have the second term, that means your coefficient b is 0. And so 0 over any number is just 0. So your axis of symmetry is just going to be x equals 0. So then your y-axis would be the symmetry. Okay? But if you see all these terms and you see b, then your axis of symmetry will be figured out using this equation. So, and the x-coordinate of the vertex, which is h. So if we don't have the form of a of x minus h squared plus k, this is another form, okay? If we don't see that form and we see this form instead, we can't really see h and k right away, right? So your h, your x-coordinate of the vertex is negative b over 2a in this situation. Okay, that's what this means. Please keep that in mind. Take a note of this. And we're going to use that throughout this lesson. Let's look at example 2. Graph a quadratic function in standard form. Graph f of x equals 2x squared plus 4x plus 3. What are the axes of symmetry, vertex, and y-intercept of the function? So first of all, we want to find the axis of symmetry using what we just learned from the concept. Use the equation x equals negative b over 2a. So this is already in our form ax squared plus bx plus c, right? So your a is 2 here, b is 4, right? So then we just need to plug it in. x equals negative b over 2a is your axis of symmetry. So negative 4 over 2 times 2 is your axis of symmetry, which is just negative 1. So x equals negative 1 is your axis of symmetry. And then now we figured out axis of symmetry is x equals negative 1. Let's figure out the vertex. Use the vertex equation as well. So first we're going to find the x-coordinate of the vertex. The equation of the x-coordinate of the vertex was negative b over 2a, which is the same as your axis of symmetry, right? You see that? So x equals negative 1 is your x-coordinate of your vertex. So then you want to figure out the y-coordinate. How do you do that? You just plug in your x value into your equation. Your equation is f of x equals 2x squared plus 4x plus 3. You just plug in negative 1 in your x. So f of negative 1 is 2 times negative 1 squared plus 4 times negative 1 plus 3. So negative 1 squared is just 1. And then that just becomes negative 4 plus 3. And so you have 2 minus 4 plus 3, which is equal to 1. Okay? So the y-coordinate of the vertex is 1. So plot the vertex, negative 1, comma 1. So your vertex now is negative 1, comma 1. And we figured that out too. Now we want to figure out the y-intercept of the function. By definition, y-intercept is when x is equal to 0. So what is it? 0 comma what is your y-intercept? So step 3, we're going to plot the y-intercept and its reflection. So first, we want to plug in 0 for x, right? So put in 0 in your equation. F of 0 is equal to 2, 0 x squared plus 4 times 0 plus 3. So f of 0 is just 3. And we already know that your value of c is the y-intercept. And this is y, okay? So as soon as you see the value of c, you know that's going to be the y-intercept. So 0, comma 3 would be the y-intercept of the function. Now we figured out all the information they wanted us to figure out, but we have to graph it. Don't forget to graph it. How do we graph it? We have all the important information, so just graph it. We have a point, 0, comma 3. And then we have the vertex, negative 1, comma 1. And then you can now plug in other points for x and figure out some other points. And that's your axis of symmetry. So you know it's going to be symmetric here. That's your vertex, so just go up and make a curve. Okay, we already learned how to graph them using points in the first lesson, so you should know how to graph it. There you go. So now it's your turn. Try number 2. You're going to graph each function, but before you graph it, it might be a better idea to figure out the necessary information first. So what are the y-intercept, the axis of symmetry, and the vertex of each function? Figure out the 3 information and graph them. Okay? Pause the video and come back when you're ready for answers. Okay, are you ready? Alright, first of all, what is the y-intercept for this one? How do you figure out the y-intercept? It's just the value of c, right? So the y-intercept is 4, right? And the axis of symmetry is negative b over 2a. So x equals negative b over 2a. Your b is 2, a is 1, because you don't see anything, but you have the term x squared. That means your coefficient is 1. So you have negative 2 over 2 times 1, which is just negative 1. So your axis of symmetry axis of symmetry is x equals -1, and the vertex will be, so that's your x value, the value of x, right? So -1 comma, plug it in, you have f of -1 is equal to -1 squared plus 2 times -1 plus 4, which is going to be +1 minus 2 plus 4, and that's equal to 4 minus 2, 2, plus 1, 3, so you have -1 comma 3. Now graph it. If you graph it, plug in some points and figure out some of your points and plot it. You know you have the axis of symmetry here where x is equal to -1, right? And your vertex is at -1 comma 3, axis of symmetry, x equals -1. The y-intercept here is 4. Or you can plot it, you can label it as 0 comma 4. Okay? There you go. That's part A. Alright. And then part B, your y-intercept should be C. So y-intercept is -4. And then axis of symmetry is -b over 2a, where b is 3 and a is -0.75. And so you have 3 over 1.5, right? Yeah, and that is equal to 2. And then the vertex, using your x, g of 2 is equal to -0.75 times 2 squared plus 3, 2 minus 4. That's equal to -0.75 times 4 plus 6 minus 4. And then minus 3 plus 6 minus 4. And then that is equal to -1. So you have the vertex of 2 comma -1. So that's your vertex, would be your vertex, and then your axis of symmetry, x equals 2. And then your y-intercept is right here where it's 0 comma -4. So look at your value of C. So that is your answer for try number 2B. Okay, let's look at example 3. Compare properties of quadratic functions. The trajectory of the water from fountain A is represented by a function in standard form, while the trajectory of the water from fountain B is represented by a table of values. So they don't have the equation, but they give you the table of values. Compare the vertex of each function. Find the vertex. Which trajectory reaches a greater height in feet? So you see that both of the parabolas are going to face down. They're facing downwards, right? So your vertex represents your maximum value, right? So if you figure out the vertex of both of the equations, we can see where it is reaching it higher, which trajectory reaches a greater height in feet. So then, first, let's figure out the vertex. We have the function here. How do you figure out the vertex? We know that the x-intercept, the x value for the vertex is in the equation of -b over 2a. So what is your a? A is -1, b is 2 here. So then you just plug it in. -2 over 2 times -1 is simply -2 over -2, which is simply just +1. So then you have the x value. How do you figure out the y value? You plug it into the equation again. So if your x is equal to 1, what is y equal to? You can figure out using your function f of 1 is equal to negative 1 squared plus 2 times 1 plus 8. So remember that you're parenthesizing your x, okay? Negative is not included. So you just square 1 first, positive 1, and then you just have negative 1, okay? And then you have plus 2 plus 8, so then you just have 9, which means your vertex is 1, 9 here for fountain A. What about fountain B? We have the table of values. We don't see we can't really figure out where the vertex is going to be just by looking at the numbers, but you see where the axis of symmetry might be, right? You see the repeating numbers, right? So you see 8 here, 5 here. That means this should probably be your highest point where there's a reflection, right? There's the change of values from here. So then that would be your vertex, negative 4, 10. Yeah. So we're just, if we are looking at a greater height in feet, which value are we looking at, x or y? We have 1, 9 and negative 4, 10. Are we comparing 1 and negative 4 or are we comparing 9 and 10? We're comparing the y value, right? The values of y, because that would be the height. It would be representing the vertical height. So 9 and 10, comparing them, you know 10 is greater than 9. So fountain B is going to be the higher one. So your textbook, look at your textbook and see their explanation as well. It's the same thing. If you compare these values, the vertex is right here. So the water from fountain B reaches a higher height. Now, if you just look at the picture, it might seem like A is higher. Don't look at the picture and just draw a conclusion from the picture. You need to be able to solve it mathematically and logically. So use algebra to solve them, not just your visuals. Don't trust everything you see. Okay? Sometimes visuals are very misleading and it may not be accurate. And that happens in real life too. All right, let's look at chart number 3. Compare the function f of x and g shown in the graph. G is shown in the graph. F of x is shown in the equation. Okay, we're looking at two different graphs. They're not the same thing. Which are the maximum values? Which means basically figure out the vertex, right? Which function has a greater maximum value? So please answer this by yourself. Pause the video and come back when you're ready for answers. Okay, are you ready? All right, how do you figure out the vertex using the equation? First of all, you can figure out the value for x using the equation. X equals negative b over 2a. What's your b and what's your a? A is negative 0.3, b is equal to negative 0.6. So your value of x is negative 0.6 over 2 times negative 0.3. That's equal to 0.6 over negative 0.6, which is negative 1. So x equals negative 1. So if you have y-intercept here, x-intercept here, your axis of symmetry is at negative 1. And your value of the vertex, your vertex will lie there too. So let's figure out the value of y of the vertex. F of negative 1 is equal to negative 0.3 times negative 1 squared minus 0.6 times negative 1 minus 0.2. and that's going to be negative 0.3 plus 0.6 minus 0.2. And if you add that and subtract it, you're going to get 0.1, right? So then you have the vertex for the graph f is going to be 1, negative 1, comma, 0.1. And what about the vertex here? It seems like by looking at the graph, this is 3. So 3, comma 0 will be your vertex. So look at the maximum values, right? You know f is also going to face downward because a is negative. When a is negative, the graph is going to look downwards. Which function has a great, what are the maximum values? So if you look at the y values, that would be your maximum values. So 0.1 for f and 0 for g. Which function has the greater maximum value? Is 0.1 greater or 0 greater? 0 is greater. No, 0.1 is greater, right? 0.1 is right above that. But yeah, it's going to be here. And that's probably how f of x looks like. So f of x has a greater maximum value. So the maximum value for f is 0.1 and for g is 0. F has the greater maximum value. That's the middle. Let's look at example 4. Analyze the structure of different forms. Mia tosses a ball to her dog. The function f of x equals negative 0.5 times parentheses x minus 2 squared plus 8 represents the ball's path. What does the vertex form of the function tell you about the situation? Now we have the vertex form, right? Do you remember the vertex form? F of x equals a times x minus h squared plus k. You can directly see the vertex, right? That's why it's called the vertex form. So you see that h is 2 and k is 8. So you know the vertex is 2, 8 right away. And a is negative, which means your parabola is facing downwards. And since a is less than 1, the absolute value of a is greater than 0 and less than 1, you know it's a little bit wider than the parent function x squared. So that's what we can tell just by looking at the vertex form. What does the standard form of a function tell you about the situation? So if you look at the standard form, you can rewrite the function in standard form, although it's a vertex form. You can solve it out. X minus 2 to the square is, you already learned how to multiply polynomials. So multiply x minus 2 times x minus 2. That's equal to, use the FOIL method, and you'll be able to see that this is x squared minus 2x plus 2 times 2, 4. And so if you combine like terms, it's x squared minus 4x plus 4. And so use the distributive property to multiply 0.5 out, basically divide everything in half. But make sure you include the negative. So negative 0.5 times 1, negative 0.5 times negative 4, negative 0.5 times 4. And you have negative 0.5x squared plus 2x plus 6 if you combine the like terms for the constant. Okay, so now we have the expanded form, the standard form. And so looking at A and B, our A is negative 0.5, B is positive 2. So looking at that, you can figure out the axis of symmetry as well, and but we already have figured out the vertex from the vertex form. But just looking at that form, you can figure out the y-intercept right away because C is your y-intercept. So the y-intercept is 6. The standard form tells you the y-intercept of the graph of the function, which is 0, 6. So we know the ball was 6 feet above the ground when Mia threw it in the beginning. Okay? So depending on which information you want to get, you're going to use different forms of quadratic functions, okay? So let's try number 4. Suppose the path of the ball in example 4 is in this equation. Find the ball's initial and maximum heights. So if it's initial heights, that's when she threw it. That's when she began, right? So when x is equal to 0, what is your height? What is your y value? And what is your maximum height? How do you figure out the maximum height? Figure out the vertex. Because the graph opens downwards, if you figure out the vertex, that would be your maximum height. And you look at the y value, not the x value. So please pause the video and try to come up with this by yourself and see, and check your solutions when you're ready. Okay, are you ready? All right, so how do you figure out the ball's initial height? That's basically when x is equal to 0. So you can convert that into the standard form, or you can just plug in 0 right away. F of 0 is equal to negative 0.25 times 0 minus 1 squared plus 6.25. And then negative 1 squared is just positive 1, so negative 0.25 plus 6.25 is just 6. So ball's initial height is 6 feet, right? It was in feet. Yeah. And then the maximum height, you need to figure out the vertex. This is already in vertex form. Do you see h and k? Remember your vertex form is a parentheses x minus h squared plus k. So your h is 1 and k is 6.25. So your vertex is 1, 6.25. So the maximum height is 6.25 feet. There you go. Right, so the ball's initial height is 6 feet. The ball's maximum height is 6.25 feet. Oops, I misspelled that. So let's summarize our lesson. We learned the standard form of a quadratic function. When you look at the standard form, you can identify the coefficients for the first and second term. And A is going to represent the coefficient of the first term. B is going to represent the coefficient of the second term. Using that, you can figure out the axis of symmetry with the equation x equals negative b over 2a. The x-coordinate of the vertex will lie on the axis of symmetry, so it will be the same as the value of the axis of symmetry. The y-coordinate of the vertex is a function of that value, okay? F of that value. So in summary, your vertex would be negative b over 2a, and y value is going to be f of that value, okay? Looking at standard form, you can figure out specific values using these. So that is just an example, okay? When your a is 2, b is 8, figure out the axis of symmetry using that equation, and that's going to be x equals negative 2. And x-coordinate of the vertex is already negative 2. So figure out your y value using negative 2 and plug it into your equation to get negative 3. So that's your vertex. Okay? All right, that was lesson 8-3, quadratic functions and standard form. So if you have any more questions, please ask Ms. Kay in class. Otherwise, we'll continue the lesson in the next video. Thanks, guys. Bye.